Hello guys and welcome back to a new video. In today's video we are going to be talking about exponential functions. We'll be talking about what they are and how to take the integral and derivative of them. An exponential function is basically a function where x or some other variable is the power of some constant. So it looks a bit like this. A to the x. Something like this. Common exponential functions that you can find are usually things like e to the x. This is a very, very common one. So you might be wondering what an exponential function does. An exponential function can help calculate exponential growth, so things growing larger by a certain period each time. They also, like e to the x, has an asymptote, or a number, or a line that they approach but don't touch. So e to the x looks like this. I'll just draw it. E to the x looks like this. You can see that as it travels along the x-axis, it approaches y equals 0, but never touches it. So we can conclude that it has an asymptote at y equals 0. Okay, now let's start talking about the applications in integrals and derivatives. So basically, when taking the derivative of exponential functions, there's like a nifty little formula derived from a differentiation rule. This formula is so you take your a to the x. So let's say, let me just rewrite this. Let's say you have an exponential function a to the x. A to the x is equal the derivative of this, which you can denote in prime form or in, like that. Well, that looks a bit like smiley face. Anyway, this is actually going to be written as a to the x times the derivative of x, and then times natural log a. So of course it doesn't always have to be x. It's basically so let's say a to the n, where n equals some function of x. Okay, then that equals a to the n times n, the derivative of n times the natural log of a. That is the formula basically. So let's go ahead and try that on the first very simple one. Let's say e to the x. This is one that is usually used, as the natural log of e is just 1. So that's pretty simple. Okay, let's do this. Feel free to stop it and have a go by yourself if you want to, but let's do this. So let's say we want to take the derivative of this function. Okay, we can plug it into the formula and get e to the x times by what is the derivative of n, or function of x, in this case being x. It is 1 times 1, and then the natural log of a, which is like the base, the constant base. So the natural log of e is actually going to be 1. Okay, so we get e to the x times 1 times 1. So e to the x times 1 or e to the x. Yeah. Okay, now let's move on to one that's a little bit harder. Let's try the derivative of e to the 3x minus 2. Try this one. Okay? Try and do it yourself first. Okay, now I'm going to give it a go. So, what we want to do is we're going to write our a to the n first, which is going to be e to the 3x minus 2 times by the derivative of n, some function of x. So the derivative of 3x minus 2, a function in this case, is going to be 3 times by the natural log of a being e. So the natural log of a, which is e in this case, is 1 times 1, so equals 3e to the 3x minus 2. Pretty simple, right? Okay, let's do the next one. How about this one? D over dx of e. Actually, let's try 7. Of 7 to the 5x plus 7x minus 3, and yeah, okay, try this. Okay, so what we're going to do first is we can actually simplify this. I'm going to write it in prime form because it's a lot faster. Oh, what the heck? Jeez. Okay, 7 to the 5, 7 to the, what is 5 plus 7? It's 12, so 12x, okay, minus 3, and the derivative of that. Okay, now we can work this out. So we're going to want to first write this out as denoted here. So let's do that. 7 to the 12x minus 3. Yep, that's it. Times, okay, then the derivative of 12x minus 3 is going to be 12 times the natural log of 7. In this case, actually, we don't have e, so we'll just denote it as natural log of 7. As we'd get a pretty nasty number out if we actually tried to get the natural log of 7. Okay, so then we can simplify this to 7 to the 12x minus 3, and then just times natural log x. 7, sorry. Yeah, so that's going to be it for the derivative part. I'll probably release a video later on a extension of this. Yep. Let's move on to integrals now. Integrals in. Okay, so when we do integrals with this, we talk about a common integral. This integral being the integral of e to the u du equals e to the u plus c. So basically, we're going to want we're going to want to try and manipulate basically the integrals to get this. So I'll show you. So let's say we get the integral of e to the 3x plus 7, okay? First what we're going to want to do is we're going to use u substitution and set u equal to the exponent, 3x plus 7. U equals 3x plus 7. And then that means that du is going to equal 3 dx. So it means that du over 3 equals dx. Perfect. So now we can write this, and then we'll bring the 1 over 3 to the front. 1 over 3 integral of e to the u du. Great. So can you see now the common integral we have? We're going to just do this now. I'm going to do this. So this is going to equal 1 over 3 e to the u plus c. Okay? So that's what you do for this. And yeah. Okay, so with integrals, there is also a formula a bit like the derivatives for taking exponential functions, the integral of. This formula looks a bit like this. So the integral of a to, n, we'll say, n equaling f of x, okay, dx. This dx, my fault, sorry. Well, technically it is a dx if it's some function of x, but for this case we'll say n. It equals a to the x over the natural log of a. Okay, so a to the n in this case over the natural log of a. Okay, so that is a formula we can use when we isolate some constant and a variable, a single variable as a power, not a polynomial. So we can actually, let's give this a go. So let's say we have the integral of 7 to the power of 3x minus 2. 3x minus 2 dx. Okay? So now what we want to do is we're going to try and isolate some constant, if we can, and a single variable, this being x. So let's give that a go, because that's what is wrote here in the common integral. Okay. So you might remember, okay, that something, right, like let's say, so a to the power of n times by a to the power of v equals a to the power of n plus v. Okay? So what we're going to want to do in this case is this. 7 times by 3x multiplied by 7 to the negative 2 dx is actually the same as 7 to the 3x minus 2. As if we use this rule here, we get 7 to the 3x times 7 to the negative 2 equals 7 to the 3x plus negative 2, which just equals 7 to the 3x minus 2. Okay? So it's the same thing, basically. It is the same thing. And then you might notice that the second 7, 7 to the negative 2, is actually a constant. So we can move it to the front of our integral. Let's do that. So equals 7 to the negative 2 of the integral of 7 to the 3x dx. Okay? Now we can simplify the 7 to the negative 2. So 7 to the negative 2 equals 1 over 7 squared, which equals 1 over 49. Okay? Great. So now we're going to put that in, 1 over 49, and then the integral of 7 to the 3x dx. Okay, what we're going to want to do now is we can actually, so if we come back to, if we go to a rule, this rule looking like this, say 7, okay, I probably shouldn't use 7 because that would give away what we're doing. A to the n times by v is going to equal a to the n times by v. Okay, instead of being added, they're being multiplied by each other. And now, can you see in this case, if a equals 7, what n and v might be equal to? Well, if you guessed 3 and x, you'd be correct. So we can rewrite this as 7 to the 3rd to the power of x dx. Okay? And we'll simplify this to 1 over 49, and then the integral of, and then 7 to the 3rd is 343. Okay? And that's to the power of x. Great. So now we've got something that sort of resembles what we have here. Okay? So we're going to use that to our advantage to get our answer. Okay, let's do this. So this is going to equal, we're going to want to write this, right, as 1 over 49 times by 343 to the x over the natural log of 343. Okay? So that is that done, but we're still not finished yet. We can simplify this even further. We made 1 over 49 from 7 to the power of negative 2, so we can revert that back to that. 7 to the power of negative 2, and then times by 343 to the power of x is equal to 7 to the power of 3x, and then over, and then the natural log of 347, is, you might remember a rule for natural logs. Natural log of, let's say, a to the n, okay, we can actually move the n to the front to be multiplied by it, which is a pretty neat rule. So we can turn this is equal to n times by the natural log of a. Okay, that's a pretty cool rule. That comes in useful quite a bit of the time. So if we go back, what is 343 to the power of x? 343. Like, what can that be expressed in terms of as an exponential? It can actually be 7 to the power of 3. Okay? So we can bring the 3 out to the front here, and then do the natural log of 7. Okay? Great. So then you might see that we can actually do 7 to the 3x times by 7 to the negative 2 over 3, and then natural log 7. Okay? Whoopsies, I almost forgot the plus c for these. Okay, and then you can see that 7 to the 3x times 7 to the power of negative 2 is actually going to equal our original. Okay, so because it's the same thing as here, so that means it's going to equal this. Okay, so let's do that. It equals to 7 to the 3x. Let me clean that up a bit. 7 to the 3x minus 2 over 3 natural log 7 plus c. Okay, so that is our video for today. The main ideas that I'd like you to remember is the rule of the derivative of a to the n. Okay, it's going to equal a to the n times the derivative of n times the natural log of a. Okay, and the integral of a to the n is going to equal, okay, a to the n over the natural log of a. Okay, so thank you for tuning in for this video. Sorry I haven't posted in a long time, but I'll see you in the next one.